Alright, let's talk about cardinality of a set. By definition, a number of elements of a set A is called a cardinality or cardinal number. Sometimes it's called also a power of a set, and is denoted by n of A or vertical bar of A. For instance, say we have set A containing x such that x is a digit. So then x has the following elements 0, 1, 2, all the way up till 9. So it's all digits. So then the cardinality of this set A, so n of A, is gonna be 10. Since we have 10 elements in this set, so we can just count them up. Now, there are some problems. More problems to work out. Now, let's focus on classifications of sets. There are finite and infinite sets, so let's dive into this. A set is said to be finite if its elements can be counted, so has a finite number of elements, and infinite if it's not possible to count up to its last element, has an infinite number of elements. Let's have a look at examples. For finite sets, we will have, let's say, set X containing X, Y, Z, U, V, W, T. Now, the second example is gonna be set F containing fruit, watermelon, pineapple, durian, mango. And the third one is gonna be some languages such as English, Russian, and so on. Now, let's move to infinite sets. Let's say the set of whole numbers W, 0, 1, and so on. The set of integers. And the last one, Q, is the set of shapes. Some examples. Now, let's get into empty set. By definition, a set which has no elements at all is called the empty set or null or void. It's denoted by the symbol letter O crossed or just empty braces, curly brackets. For instance, say we have set A containing all x's such that x belongs to the set of all natural numbers, and simultaneously x is less than 2 but greater than 1. So you can notice that there are no natural numbers satisfying this inequality. So you cannot find any natural number that can be less than 2 but greater than 1. So set A is definitely an empty set. So there are no elements in it. Alright, Singleton set. A set S which has one element only is called known as singleton or unit set. So obviously the cardinality of this singleton set is gonna be 1 since it has only one element in it. For instance, let's say set X containing the element 1, so it's gonna be singleton set, one element only. Now, let's move to equal sets. By definition, two sets A and B are said to be equal if every element of A is in B and every element of B is in A. So if only if they contain exactly the same elements. And it's written by A equals B. So normal sign, equality sign is to be used. So for instance, say we have set A containing 1, 3, 5, 7 and set B has the following elements 3, 5, 1, 7. Clearly they are precisely the same sets. They has the same elements. So the only difference is just the order of the elements being switched. So they are equal sets. Some problems? More? Now, let's focus on subset. Very important idea. If A and B are two random sets such that each element of the set A is an element of B, then it's said that A is a subset of B, and it's written as A a subset of B. So this symbol actually means the relationship of being subset. So it's kind of one-sided letter U in this symbol is actually reminiscent of the less or equal symbol inequality for numbers. So the way we would say is A is included in B, or B includes A, or B contains A. The set B, which is going to be bigger, let's say, is also called the superset. So A is a subset and B is a superset of A. Now, let's have a look at example. So, say we have set B containing the elements 1, 2, 3, 4. So, set A is going to be subset of B. So, A has elements 2, 3, 4. As you can see, 2, 3, 4, all of elements from A, they belong to B. So, A is a subset. Second example, let's say we have the set E. It's going to be actually the whole numbers. So if we take sum of the elements from E, so we can get the subset D containing 1, 2, 3. Next one, set Y containing items that you wear. So if we pick any items, let's say shorts, pants, shoes, socks, it's going to be subset. So X is a subset of Y. The last example, so colors that belong to a rainbow. So if we pick any colors, let's say red, green, blue, so this set C containing these colors is going to be the subset. A couple of remarks. The first one, the set A is a subset of itself. The second example, the empty set is a subset of any set B. The first two kind of properties, I would say it's vitally important. Number three, if A is a subset of B and B is a subset of A, then A equals B. The last one, if A is a subset of B and A is not equal to B, then A is said to be a proper subset of B. So it's denoted by A is a symbol for proper subset. So it's very similar to strict less or strict greater. Now let's move to power set. A set of all subsets of a given set A is called a power set of A and designated by P of A. So that's just symbol for subset. By definition, P of A consists of all subsets X such that X is a subset of A. So for instance, consider set A containing A and B, two elements, then the power set P of A is gonna be the empty set, the singleton sets A and B, and the set A itself. So only 4 elements. Notice that the elements of the power set are sets itself. That's why we're using the curly brackets. If the power of the set A is m, then the cardinality of the power set is gonna be 2 to the nth. Now, let's talk about universal set. The set which contains all the other sets under particular consideration is called a universal set or universe. Symbol U is taken to mean universe. In other words, in particular discussion, U has to be fixed, and it's considered all the sets in the discussion are subsets of U. For instance, say we have set A containing 1, 0, 2, and set B containing 1, 2, 3, set C 2, 4, 6, and 8. Then U containing the following elements 0, 1, and all the way up till 8 is gonna be universe, or any other superset also might be taken as universe. Now, let's move to Venn diagrams. So they're meant to be to represent sets pictorially. So the universal set U is represented by the interior of a rectangle and its subsets by circles or any closed shapes. So again, the universal set U is represented by any rectangle, and all sets under this consideration, it's gonna be inside of this U, so we could use any shapes for them.